So hi, my name is Janke, and today my talk was titled Dealing with Bad Architecture Decisions. But as I was putting the slides together, I realized it's more about learning from bad architecture decisions, so that's where we're going with this. So I'm going to be talking about a project I worked on last year, and it's like all projects, we ran into like some very last-minute roadblocks that kind of almost messed up everything, and like we're going to be talking about that. So first I'm going to give background on what the project was, just to kind of understand what we were working on. Next is like what actually happened, what the issues were, how we like kind of fixed them. And then finally, some ideas for how to prevent this from the future and maybe how we could have prevented it this time. Okay, so first of all, yes, we're doing background. And so I'm a software engineer at Etsy, which if you're unfamiliar with Etsy is a website where people can put up storefronts for like selling items like handmade items, vintage, and like craft supplies. And so it connects people like sellers to buyers. I personally work on the seller side of things. So my team works on tools to make it easier for sellers to manage their orders and like ship items. And so like for example, let's say a seller wants to know what orders are in progress that they need to work on and that need to actually be shipped today. That's the kind of question that like my team wants to make it really easy to answer. And so up until now, this was how they did it. This is the page, this is the order management page. And this was where they would go to like manage their orders. So as you can see, there's some functionality for answering the one question. We have a couple of tabs. There's an open tab and a completed tab. And the open, which we can use to tell which orders are new and haven't been done yet. And then after that, we also have some sorting functionality. So we have, you can sort by your most recent orders, which is like also helpful. But if we go back to the question, it doesn't quite answer it. Like for example, open orders includes both new orders and orders that are in progress. So like we can't tell just by looking at this which orders are in progress. And also, there's nothing in here about like which ones actually need to ship today. We just know which orders came in first. So we could definitely do better in this. So my team was like, hey, how about we redesign this page to be more useful? And so this is the new orders page. And so this is, and so we have a lot of cool tools that we added to this. So first of all, instead of just having open and completed, now sellers can add their own tab. So here I've added like an in progress tab, if you can see that at the top left. And we also have new filters, so now you can actually filter by a ship date, not even just like which orders are due to ship today, but like tomorrow or within the next week, et cetera. So this was the project we were working on, and my part of the project was to do the back-end logic for supporting these like new filters and order states. So yeah, so basically determining which orders we want to show on the page given like the parameters that the seller selected. And that's where like the whole story starts. So so next is what actually happened. So even before we started this project, we knew that we wanted to use a search index, like specifically Elasticsearch. And this was back in July of 2016 when we were first planning out things. And so like, why did we want to use a search index? Well, first of all, we knew we wanted to support text search. So like, let's say a seller wanted to look for orders that were like cat hats. They could search for cat hat and have them come up. And we're like, oh, we could just like run the rest of the thing using the search index also. And there's like a couple other cool reasons for that. So first, search indexes are like really fast at like queries, like complicated query filter things that we could set up. Next, search indexes are just kind of cool. Like it sounded really interesting. And third, my team, we did not know anything about search indexes, and we thought it would be a good opportunity to learn more about how they worked. And so I spent the next 3 months, this was September through November, setting up the search index. So going back, so what was involved in that? So back to what orders are in progress and need to be shipped today? What data do we need to answer that question? So we decided, okay, so so an index is made up of like lots of documents, and each document like represents like an order in our case. So what kinds of information would we need in that document? So we'd obviously want something like an order state, like a string that's like new or in progress. We'd also want like the ship date, like an epoch timestamp, and we could use that to figure out which ones are in progress and which ones need to ship today. And this is like an Elasticsearch document. Okay, and so we actually have all that information already like in our system. So at Etsy, we have MySQL databases, which are like our source of truth. So we have an orders database table. It has like an order ID, an order state. It has like the ship date, so it has the information we need. And it also has like some other rows and columns and like lots of other stuff. And so normally you'd think you could just send that straight to the index, right? But the index is like kind of picky, and so it only wants some of the data. So if you look back, there's like a few random fields in there. Like there's like some weird variants. There's like things you don't even know what they are just by reading the field names. And the index is like, I don't want that. And the index is also wants it to be specially formatted. So like for Elasticsearch's APIs expect JSON blobs. And if you're not familiar with a JSON blob, it's just kind of like this bracket notation formatted stuff here. And so the index is like, I want this. I don't just want your random database junk. And so how do we get from the MySQL order database to this Elasticsearch document if the index actually wants a nice JSON blob? And the answer to that, so this is now we're going into Etsy-specific search architecture stuff. And this is how we personally handle it. We have another MySQL database table, which is our intermediate kind of staging table. And that's and so there is we stick the order ID, which maps to the JSON blob, which is what the actual index wants. And we call this table the database search table because we're really great at naming things. It's between the database and search. And then we also call this just DB search is what it abbreviates to. So I'm going to be saying DB search a lot. And when I say DB search, I mean this kind of funky middle staging table. So next, so this is the basic flow of data. So we go data from database into DB search into the index. And so what are the stuff do we have to implement on our end in order to get our index to work? Well, we had to set the index itself, but that's kind of basically plug and chug and pretty straightforward. We had to build the DB search table, also pretty straightforward. The path going from getting data from DB search to index was actually already set up at Etsy a while ago for other similar indexes, so we could just kind of use that thing that was already built. But then getting the stuff from the database into DB search was something that we did actually have to implement, and to do that we used Drift. So of course you're probably wait, what is Drift? So that's a good question, because a lot of people at Etsy also do not know what Drift is, and I had no clue for a lot of this project. So this is an internal tool that we built at Etsy, that all it does, it's a loop that first it finds orders that have been updated, it takes that data, turns it into a JSON blob, and then sticks the table into DB search. And just kind of goes around and keeps doing this. So so it seems pretty straightforward. How does Drift actually find the updated orders? Well, to explain this, I kind of like to think of Drift as a small child on a road trip that's always bugging its parent. So in this case, Drift is a small child. The database is the very tired parent. And then instead of saying, are we there yet, the database is not the database, Drift is hey, do you have new orders? All the time, continuously on loop, constantly asking, hey, do you have new orders yet? So it keeps track of the timestamp as it does this. So it'll be hey, database, have you seen any new orders since 1 second ago? How about since half a second ago? And it just keeps asking and asking and asking. Which is probably would be very annoying in real life, so luckily we don't have to deal with that. So because there's always new orders coming in and there's always orders being updated, it takes a lot of time for orders to actually get picked up by Drift. So I mean, it takes roughly a minute for an order, once it's been updated, for Drift to store the new copy in DB search. And then from there, it doesn't actually take, so it can be more actually too if there's higher loads of orders at that time. Sometimes Drift can fall behind by 15 minutes or more. And then to get from DB search into the index, it takes approximately a second, which when you compare it to a minute is negligible. So most of the time for the index to update is from getting the data just into DB search. So that means overall it takes approximately a minute for the search index to update on our system, which is a really big issue. So let's go back to our app. So let's say a seller has a new order and they want to move it into in progress. So they move it to in progress, they refresh the page, the order seems to be stuck in the new state, and it stays stuck for they keep refreshing it, and it keeps staying there for about a minute until it inexplicably moves to the in progress state, which is obviously really, really, really slow, and a really, really bad user experience, which is not acceptable. So we realized this fact that our system was just basically unusable in December, and the product was scheduled to launch in January. So this is, yeah, it was a big issue. And this was after 3 months of working on it that we realized it was broken. And so that means we had to come up with a last-minute hacky solution. So if you remember correctly, this was our flow, so database to DB search to index. So we're okay, how about we make a new database table that's basically an index. It has the same fields as the index does. It's just in a table. And since it's a database table, we don't have to rely on our hacky Drift solution to do the updates. And so instead, we can just it'll be instantaneous. So then maybe your next question is, wait, do we actually need the index? Why didn't we just do this hacky solution from the beginning? And that's because we still needed to support text search, which is not very easy to do with MySQL databases. And so what does a query look like now? So let's say we're okay, what cat hat orders are in progress? So first you would do, it's a two-step process. So first you do a query to the index, searching for a string cat hat. And the index sends back a list of order IDs being okay, these are the ones that contain cat hat. And then we take that list of order IDs and we go to the actual new database table, the pseudo index we built, And then we are like, hey, which of these are in progress? So it's this really like convoluted dual system that confuses everyone, and it's completely non-intuitive when you look at it. And so remember, this was like all a year ago when we were building this. As of today, it's still in place. And I feel like this is just another takeaway that if you build something and it's really hacky and not good, it's probably going to stay like that forever, so just be aware of that. Yeah, so how can we prevent this in the future? Because that's pretty terrible, and I feel pretty bad about it. So first question is, why wasn't there a backup plan? Like I said, this was completely new technology. Like maybe our team should have had something in place in case this all didn't work. And like we were working on Drift earlier, like we probably knew that there was some weird like time delays, like why didn't we think about it? And so we did actually have a backup plan. So we knew other teams were using search indexes and that they had actually managed to have like instantaneous updates, that they could like force updates. And we're like, oh, okay, we'll just like do what they did. We'll just copy it and like do instant updates. But this is like a very half-baked, not really well-formed plan. And of course that came back to like, you know, that made trouble later on because it turned out their use case was different enough that what worked for them did not work for us at all, and it would not have worked in our situation, so we could not rely on that option anymore like we thought we could. So lesson 1 is make sure your backup plan actually works. So you should actually be dedicating, when you're like even creating timelines, actually dedicate time to verify that your backup plan will do what you think it does. You can even spike on it, which is a term I got from a previous manager, which basically means you create like a quick and dirty version of your plan as like a proof of concept just to verify that it'll work to build confidence. Next, for our next lesson, we're going to go all the way back to the beginning when we were first like, hey, let's use a search index. And like, one question is like, why? Why are we using a search index? So the reason why was because like from the beginning, it was just kind of like implicitly assumed. And like, I didn't really think to question it. Like my coworkers, my manager, we didn't really think to question it. We were just kind of like, okay, yeah, search index. So from this, I think the takeaway should be like initial architecture decisions should not be final, which seems kind of obvious, but there's ways to like enforce that and remind yourself. So like first of all, you can make it clear from the beginning that the architecture is open to discussion. Like even like tickets and descriptions of the task, you can be like, okay, we're planning on using Elasticsearch, but you know, we'll keep an eye out if there's any issues. Even more importantly is you can hold regular retrospectives where the architecture is evaluated. Like if it's a longer project, you can get back together every month. And you can get together every month and be like, hey team, like, do we think this is still working for us? Is this like a good solution? Do we see any like big problems that could possibly arise? It's like very helpful. Question 3, so I mentioned earlier, like, okay, we had signs about like drift being an issue. I was the one who was working the closest on the system. Like, why didn't I personally, when I was like setting up drift and being like, oh, it takes about a minute for stuff to update, like, why didn't I realize how big of an issue this was? So this is like not as like an excuse, but as an explanation. Going back, so our team experience on the search stack was 0. And so it was like very intimidating. It was completely new technology. I felt behind, so like the whole time, this was me. I was like just panicking and flipping out. So like, because, yeah, so I was like panicking and flipping out because I kept thinking I was like super behind. I'm like, okay, I'm really behind, really behind, really behind. I always have to keep focusing on like the next task. And I always assumed, I was like, okay, I thought I was so behind that I never thought to take a step back to actually examine what I was doing and make sure it was the right thing to be doing at that time. And so lesson 3, which I think is just a good life lesson in general, is try not to panic. And that helps a lot. So designate time to make sure that you're on the right track. Even if you're like, oh man, I'm a month behind, like still check to make sure you're on the right track. As a side note, you're probably not actually a month behind. Like I was the only one who thought I was a month behind on this project. Like the rest of my team, my manager, they all knew that like stuff takes time and they had much more realistic expectations than I did. So yeah, so learn new things takes time. Don't put too much pressure on yourself. Okay, so review. So these are the 3 lessons that I covered. So make sure your backup plan actually works. Initial architecture decisions should not be final. And third is try not to panic. But I think also, if you look at this as like a broader thing, there's also like a meta lesson here, which I guess kind of ties into the try not to panic part. I think it's just looking back on past mistakes you've made or past projects that didn't go quite as well as you have hoped. It's like a really good exercise to do. Like I feel like I learned a lot by looking back on this and being like, okay, what could I do better next time? what's like really useful. And so even if like these actual lessons don't necessarily apply to your stuff, I think this part like applies to everyone, and it's just like a good practice. And like the idea of doing like being critical and looking at your stuff, but also like not being too not judging it, but also mostly just trying to learn from it, I think is really good. So yep, that is my talk, and thank you very much for listening. Yeah.